Alright, so I just finished this video, or this problem. Let's do some more. Alright, so we're going to graph this function. And we're going to graph it by looking at the roots first. Okay, and so you'll have a pretty graph. Alright, so this guy, so these are all factors. This guy, negative x, we'll set each factor equal to 0. We get x equals 0. And the multiplicity is 1, like there's no exponent. So that means it's going to cross. X plus 3 equals 0. So we get x equals negative 3. There's no exponent right there, so that means there's an invisible 1, so it will cross. And then we have x minus 5 equals 0. So, negative 3 right here, sorry. We get x equals 5 right here. And there's no exponent, so it's odd. There's an invisible 1, so it will cross. All right, then if we get a negative for our leading coefficient, it's right there. And then if we did x times x times x, we get x third. So we have a negative leading coefficient and an odd degree. And so then it means it goes up, down. This guy goes up, this guy goes down. Okay, and I'm looking at that little chart I made from like 2 videos ago. I told you to make a little chart on the side. All right, and so all of this says cross. So right here we need to cross. Right here, we know we're going to cross this way because these two lines need to connect. These two need to connect, so the only way to connect is like that. So this is basically what our graph looks like. And how can I verify that? I'm going to go to y equals, and I'm going to type negative x, parentheses, x plus 3, parentheses, x minus 5. Like that. Okay, I'm going to go to window, which is right there. Or I'm just kidding, not window. I'm going to go to zoom, zoom. And I'm going to go to number 6. So standard. I'm going to push enter. And so that's basically what ours looks like. I'm going to go push zoom again. I'm going to push number 3 to zoom out. And so there it is. And so there's our graph. We didn't need a graph calculator. Where's the remote? All right, intermediate value theorem. Okay, there's 2 ways we can use intermediate value theorem. We can use intermediate value theorem for a 0, like an x-intercept, or we can use an intermediate, to find a maximum or a minimum, like to see if there's a maximum or a minimum. We're going to find it for the x-intercepts. And I'm going to explain it as we do a problem. All right, so what we do is we're going to plug in 1 and we're going to plug in 3. If we get a positive number, doesn't matter what it is, doesn't matter if it's a whole number, fraction, decimal, doesn't matter. If we get a whole number for one and a negative number for another, then that means it crosses the x-axis at some point, and there's a 0, because 0 is between a negative and a positive number. If we get 2 positive numbers, there's no x-intercept, there's no 0. If we get 2 negative numbers, there's no 0. So what we're looking for when we substitute these guys in is 1 positive and 1 negative number, and then we say yes, there's a 0, there's an x-intercept, a solution, a root, all those mean the same, that exists between these 2 numbers. All right, so we're going to say f of 1 negative, that should be parentheses, 1 to the 4 is 4, 1 squared. We'll see what that is. We're going to do f of 3. Negative 3 to the 4th minus 4, 3 squared. Okay, and I'm just going to type it in my calculator. Negative 1 to the 4th minus 4, 1 squared, negative 3 to the 4th minus 4, 3 squared. All right, so I got negative 5 and negative 117. I didn't get a positive and a negative. Hang on. Okay. Checking out something because I want to show you something. Okay. So that means there's no 0 between 1 and 3. Okay, let's do another problem. All right, let's do this guy. Let's do, this is what I was looking at. Okay, this, I knew this problem was coming up. Let's do positive 4 instead of negative 4. Can we do that? All right, now let's do it. All right, so we're going to do f of negative 3, see what we get, and then we're going to do f of 4 and see what we get. Negative 3 to the 4th minus 4, negative 3 squared, and see what we get. We're going to do negative 4 to the 4th minus 4, 4 squared. Yeah. All right, so I'm going to do negative 3 to the 4th minus 4, negative 3 squared. And then I'm going to do 4. All right, so when I plugged in negative 3, I got negative 117. When I plugged in positive 4, I got negative 320. All right, so there's not necessarily a 0. I shouldn't say no. I should say there's not necessarily one. It's inconclusive is what we should really say. Right? So not necessarily a 0 between 1 and 3. Right, I want us to do another problem. I want to show you what that will work. I want to come back to that. If we do this guy, hang on. All right, let's do this problem. Let's change this a little. Okay, I'm going to do one more problem. I want to show you what that works. All right, I'm going to change it to this. Change this to plus. That's what it should have been. I just did a typo. And then change this to negative 3, negative 1. All right, so we're going to do the same problem. Or we're going to do this problem same way. So we're going to do f of negative 3, f of negative 1, and see if we can come up with any evidence that there's a 0 exists between the two. So negative 3 to the 4th plus 4, negative 3 squared. Negative 1 to the 4th plus 4, negative 1 squared. 3 plus sign. I get negative 45. Now we're going to do negative 1. Okay, and I get positive 3. So one's positive, one's negative. So yes, there's a 0, a root, a solution, an x-intercept is between x equals negative 3 and x equals negative 1. All right, let's look at this here. Okay, so local extrema just means the minimum and the maximum. So there is 1, 2, 3 of them. There are 2 maximums, and they are at, we're going to kind of estimate, okay. Negative 1, comma, 2.5. And 1.5, comma, 5.5. I just want you to practice what a minimum looks like, what a maximum looks like. A maximum is the top of the hill, a minimum is the bottom of the hill. There's, I should say 2. There's one minimum, he's right here. Oh, it looks like 0, 0. Probably a little off. All right, the maximum, I mean the y-intercept is where it crosses the y-axis, so it kind of looks 0, 0. The one you have, you'll be able to like for sure tell. All right, the zeros are where it crosses the x-axis, so that's right here, and right here. So we'll say negative 2, 0, and 2. All right, it crosses right there. It means it's odd. Touches right there at 0 and turns around and it crosses right there. So that means, the multiplicity at 0 is an even number, it's squared. So the factors for negative 2 is x plus 2. The factor for 0 is just x. So I'm just going to write them in the front. And then the factor for positive 2 is x minus 2. All right, and so cross, you just have a 1. For a touch, you put squared. And so when we multiply this guy out, he'll look like this. And so we can verify that by just typing in our calculator. X squared, parentheses, x plus 2, x minus 2. And he will look like our graph. Oh, one more thing. This goes down, down. And so if we look, down, down means the leading coefficient is negative. And that the degree is odd. So that's 2 plus 1 plus 1, so it's 4. So we just needed a negative sign. All right, and so one more time on min and max. All right, there are 1, 2 local extrema. There's 1 maximum. He's right here. We'll say he's 2, 4, 6, 2, 4. So 4, comma 50. We're kind of estimating. And then there's 1 minimum. He's right here. And he's, I don't know, 5, comma negative 65. Okay, and so I just wanted you to practice that. All right, so go practice putting everything we've learned together about polynomial functions, and I'll see you in the next video.